Okay, today we'll discuss about electric potential difference between 2 points denoted by VAB and electrical potential at a point, given point, denoted by VR. So actually, what is electric potential difference between 2 points? It is nothing but work done in moving a unit positive charge from A to B. Okay, and what is electric potential at a given point? It is nothing but the work done in moving a unit positive charge from infinity to the given point. We'll see about these two topics today. Let us consider a charge Q which is placed at the origin in this Cartesian coordinate system. It is placed at the origin. Due to this charge, electric field is generated, shown by these three lines denoted by E bar, that is electric field due to Q. Now let us find out the work done in moving a test charge from A to B. This is the path in which the test charge is moved from A to B. It is not a straight line. It is curved in nature. Okay. Let us consider a small differential length dl and find out the work done in moving the charge through the small differential length dl, and then integrate it from position vector RA to RB to calculate the complete work done in moving charge Q from A to B. Okay, let us consider a small differential length dl and find out the work done, that is dw, which is equal to force applied on Q, let it be F dot dl. This is a dot product, but we should understand that the charge Q is a positive charge. Whenever it is placed in the electric field of Q, it will be repelled by this charge. Okay, so we have to hold this charge and then move it slowly from A to B in order to find out the work done. Otherwise, it will move away from the charge. Okay, we have to denote it by minus sign because the work is done by external force here. So minus F dot dl. dw is equal to minus F dot dl. Since there is angle between electric field and this dl alpha, this is equal to minus F into dl cos alpha. This is the dot product now. Okay, F into dl. Actually, F is a vector, dl is also vector. So we'll get F dl cos alpha. Since the position vector is R is collinear with electric field, it can be written as minus F dr, where dr is equal to dl cos alpha. We will use this expression now. dw is equal to minus F into dr. What is F? F is external force. Without using external force, we cannot move the test charge from A to B. So it is denoted by minus sign. Now we integrate it from RA to RB to get the work done, to find out the work done. RA to RB. That is dW. If you integrate, you will get W is equal to, that is total work done in moving charge Q from A to B. So minus integral F dr AR cap, which is equal to, we know that F is equal to Q into E, that is force on the test charge Q whenever it is placed in the electric field E, that is Q into E. How we will get this? We know that force F is nothing but force experienced by unit positive charge whenever it is placed in the electric field. So what is force experienced by Q when it is placed in the electric field, which is equal to Q into E. I am using this expression in place of F. So W is equal to integral minus RA to RB. F is nothing but Q into E into dr AR cap. But E already we have derived in the earlier classes, where E is equal to 1 by 4 pi epsilon naught Q by R square. Q by R square AR cap. So I will replace this E by this expression. Then we will get W is equal to minus integral RA to RB, RA to RB, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught. In place of E, I am writing this into Q by R square, and Q I am taking common outside, dr. AR cap is there. AR cap gives the direction of the force or the electric field. So key taken outside, integral RA to RB, 1 by 4 pi epsilon naught also you can bring it outside, minus Q by 4 pi epsilon naught Q by R square dr AR cap, which is equal to minus Q by 4 pi epsilon naught integral RA to RB. Q also I am bringing out 1 by R square dr. So W is equal to minus Q into Q by 4 pi epsilon naught. If you integrate 1 by R square, you will get minus 1 by R from RA to RB limits, which is equal to minus Q into capital Q by 4 pi epsilon naught. Minus and minus will get cancelled. You will get 1 by RA, 1 by RB minus 1 by RA. To substitute the limits, we will get this. But actually, what is the electric potential? Is nothing but moving a unit positive charge, work done in moving unit positive charge from point A to point B. But we have found the work done in moving a test charge from point A to point B. That charge is Q. So if you divide it by Q, we will get the work done in moving a unit positive charge from A to B. So I am dividing this work by Q. So we will get this potential difference between 2 points VAB is equal to W by Q, which is equal to this minus already got cancelled. So if there is one, here it should be positive. So we will get Q by 4 pi epsilon naught into 1 by RB minus 1 by RA. If you open the brackets, we will get Q by 4 by epsilon naught RB minus Q by 4 by epsilon naught RA, which is equal to VB minus VA. Okay, this is the potential difference between 2 points, and its units are volts. Potential difference between 2 points. Now let us find out the electric potential at a given point. Let that given point be B, whose radius vector is R, and it is the charge is moved from infinity, that is A is at infinity. Okay, A is at infinity to B. So the limits will be changed from infinity, that is RA is infinity, RB is nothing but R. Position vector is R, and this RA is position vector is infinity. So if you substitute those values, we will get 1 by R minus 1 by infinity. 1 by infinity is equal to 0. So potential at a given point whose position vector is R, which is equal to 1 by 4 pi epsilon naught into Q by R into AR cap. This is the voltage. So measured in volts. We will do a numerical on this so that you can easily understand. We have derived electrical potential at a point which is equal to, that is VR is equal to 1 by 4 pi epsilon naught into Q by R volts. This is the potential at a point. That is, the charge is placed at the origin. Let this be x-axis, y-axis and z-axis. Charge is placed at the origin and we have found out the potential at this point P, let us say. Whose position vector is R. Okay, when the situation is like this, the potential at this point VR is equal to this one, 1 by 4 pi epsilon naught into Q by R volts. If the charge is not at the origin, it's some other place like this. If it is Q is not here at the origin, let us suppose Q is here, Q is here. Whose position vector is R1 and this is the point where we have to find out the electric potential due to charge Q. Let this point P be whose position vector B is equal to R. Then let us find out the potential at this point due to Q. Let this be vector B X. Then this is a triangle. These two have same orientation and this is in the opposite orientation. So R1 plus X is equal to R. So X vector X is equal to R minus R1. So substitute here, then we will get VR is equal to 1 by 4 pi epsilon naught into Q by, previously Q was at origin, now it is at some point whose position vector is R1. So now it is, instead of X I am writing R minus R1. Okay. In the same way, if there are n number of charges, we can extend this formula. That means let us suppose it is Q1 and Q2 is here and Q3 is and so on Qn. If Q2 is here, whose position vector is R2, let us say. Position vector is R2 and potential at the same point will be sum of these two, potential due to Q1 plus potential due to Q2. So plus 1 by 4 pi epsilon naught into Q, this is Q1 let us say, then this is Q2 by R minus R2. So this can be extended to Qn 1 by 4 pi epsilon naught by Qn by R minus Rn. Okay, if there are n number of charges like this Q1, Q2 and so on Qn and whose position vectors R1, R2, R3 and so on Rn, then potential at this point will be equal to, that is VR is equal to 1 by 4 pi epsilon naught into Q1 by R minus R1 plus Q2 by R minus R2 plus and so on Qn by R minus Rn. This can be written like this: 1 by 4 pi epsilon naught sigma k running from 1 to n q k by r minus rk. If k is equal to 1, it will be first term. If k is equal to, it will be second and so on. It covers all n terms. So let us do one or two numericals on this so that we will get the clear concept on electric potential. First question, first numerical. Two-point charges minus 4 microcoulombs and 5 microcoulombs are located at 2 minus 1 3 Cartesian coordinate system, 2 minus 1 3 and 0 4 minus 2. At these points the Q and Q2 are located respectively. Find the potential at potential at 1 comma 0 comma 1. At this point we need to find out the electric potential assuming zero potential at infinity. Assuming zero potential at infinity. Assume zero potential at infinity. 2-point charges. Let us take Q1 and Q2. Q1 and Q2 are the point charges. Whose coordinates are 2 minus 1, 3 and coordinates of this second point charge 0 4 minus 2. Okay. Let this be position vector R1 and let this be position vector R2, and we need to find out the potential at point P, that is 1 0 1. I have taken arbitrarily these points, exactly not correct. So we need to find out the potential at this point due to Q1 and potential at this point due to Q2. Okay, this is the diagram for this question. What is R1? These coordinates are 0 0 0. What is the formula? Formula is VR is equal to 1 by 4 pi epsilon naught Q1 by R minus R1 plus Q2 by R minus R2. Okay, and P, its position vector is R. So by using these coordinate values, coordinates are given for all the points, so we can find out the vectors. So position vector R1 we should find out, and R. For Q1 the potential at this point can be calculated. So let us say what is R now. R vector is, this is head and this is tail, so head minus tail. 1 0 1 minus 0 0 0. So vector R is equal to 1 0 1, and R1 is equal to 2 minus 1 3 minus 0 0 0. 2 minus 1 3 minus 0 0 0 will get the same thing, 2 minus 1 3. So for this part we know R and R minus 1. So what is R minus R1? R minus R1 is equal to 101 minus 2 minus 1 3. 1 minus 2 is minus 1. 0 minus 1 is 1. 1 minus 3 is minus 2. Okay. So its magnitude is equal to under root 1 square minus 1 square plus 1 square plus 2 square is equal to 1 plus 1 2, 2 plus 4 6, root 6. So similarly we will find out R minus R2 also. What is R2? R2 is equal to R2 is equal to same thing, 0 minus 0, 4 minus 0, minus 2 minus 0. So R2 is equal to 0, 4 minus 2 only, and R is 1, 0, 1. So R minus R2 is equal to R is equal to 1, 0, 1. So R minus R2 is 1 minus 0 is 1, 0 minus 4 is minus 4, 1 minus 2 is 2. So its magnitude is equal to under root 1 square plus 4 square plus 2 square, 21 under root. So substitute in this, VR is equal to 9 into 10 to the power of 9, that is 1 by 4 pi epsilon naught is equal to 1 9 10 to the power of 9. Q1 is minus 4, the 10 to the power minus 6 I will take out micros 10 to the power minus 6, minus 4 by R minus R1 is root 6 plus Q2 is 5 microcoulombs by root 21 10 to the power of minus 6 volts. So VR is equal to, finally we will get minus 5.87 kilo ohms, minus 5.87 2 kilovolts, this is the answer, kilovolts. So with this we have completed the topic electric potential difference between 2 points A and B, and also electric potential at a given point whose position vector is R.